Hello, and welcome to the CHEM111 Flex Lab on acid-base titration curves. In this experiment, we're going to titrate a weak acid with a strong base. We're going to measure the amount of volume of the base added and plot it against the pH that's generating that titration curve. In addition, we're going to evaluate that titration curve for important regions known as the buffering region, the half equivalence point, and the equivalence point. A titration curve is a plot, and it's a plot of volume of titrant added versus pH, so the total volume of titrant added. The buffering region is very important. This is when the conjugate acid-base pair is present, and we're getting that buffering. Half equivalence point is also important. It's when our pH equals our pKa, so that'll help us find the Ka of our acid. And remember from last time in 110, equivalence point was when the moles of acid equals the moles of base. Now that's going to be a little different in a weak acid titration because you don't expect the pH to be exactly 7. In addition, we're utilizing indicators again so that we can note when the color change occurs. Some essential formulas from 111 that you're going to want to use in this lab is the good old Henderson-Hasselbalch equation, as well as our dilution formula, and our, as I like to call it, fun box, our pH calculations.
So we've got a couple of experiments where we specifically need to be worried about our glove protocols. And those experiments are the solution concentration, the titration standardization, and the titration for the vinegar concentration. So when we talk about those experiments, it's absolutely necessary that we wear gloves for the entire experiments. For the other experiments, gloves are recommended. They're not necessarily necessary. It's never that we don't want you to wear them, but you don't have to wear them for the other experiments. For these, it's necessary. So I want to show you how to properly put on a pair of gloves, how to take them off, and then talk about what are proper protocols for using those gloves in those experiments. So let's talk about how we put those gloves on. So we're going to take gloves out of this container. Here's one, here's two. I'm going to set those down. We're going to make sure that we put them on appropriately. So we want to make sure that we get our thumbs into the thumb spots on our gloves. So that's one. I want to get that over my watch because I want to make sure I don't kill my watch while I'm wearing it. And then I have my second one, if I can get this thing sorted out because they're all shoved in there. Not necessarily easy to put on. Some people take their rings off before they do this. It depends on how big your rings are. I have ones that are tiny so I don't break through my gloves. That was a decision we made. But these are how I put them on. Putting them on is the easy part. Okay? Taking them off is not the easy part. When I'm in the lab and I'm working with these gloves, everything is fine. If I have to leave the lab for whatever reason, I need to go to the bathroom, I need to take a phone call, I need to eat something, I need to do something outside of the lab, including taking a drink, then I need to take these gloves off. So if I'm going to take these gloves off, I can take the first one off fairly easily, right? Fairly simple. But when I go to take the second one off, I want to hook my fingers inside of it, grab a hold of the inside, and then pull it off like that so that I'm holding the inside when I'm dealing with it, not the contaminated outside part of the glove. And then I take those off. I'm then going to wash my hands to make sure that I get anything off of my hands that shouldn't be there, because sometimes we accidentally get chemicals inside, okay? And then I'm going to go do whatever I need to do. When I come back to the lab, I'm going to go to the front bench. I'm going to wash my hands again, just because I'm paranoid. And then I'm going to put on another pair of gloves. And I'll do that before I handle anything in the normal part of the lab. Okay, because chemicals can be just about anywhere. So we want to make sure that we're dealing with clean hands before we put them back into those gloves. Now, things that we need to make sure that we're dealing with when we talk about these experiments. We put those gloves on before we handle anything, because you may not be the first lab for that week. So the things that we're dealing with may not be as clean as we want them to be. So we want to make sure that we're dealing with, everything in gloves. So make sure we've got those dealt with the gloves on. Anything that we deal with in the lab needs to be done that way. Anytime anybody is working with anything, doesn't matter if it's chemical or not, for those labs, we need to be wearing those gloves, okay? So I think that's everything I need to talk about with the gloves. So thanks, guys. I appreciate it.
So welcome students for this acid-base titration lab. What we're gonna do is we're gonna talk about titration curves. You're gonna do strong acid, strong base titration, and then you're gonna do a weak base, strong acid titration. You're gonna need a couple of materials for this, and the first thing I'm gonna show you is how to calibrate, which is probably the most important part of this lab, and probably what's gonna take you the longest. To set up, you're gonna need a lab quiz, you're gonna need your drop counter. You're also gonna need this little stir bar, which should be with the drop counter. You're gonna need this plastic burette, which normally we use the big burette. We're gonna use this one. And then you're gonna need a clamp. So, and then also you're gonna need your pH probe, of course. So the first thing before you set up is to plug it in. This one is very different from what you're used to. There is a plug at the top of this, and then you would open it, and then it goes in there. It doesn't go on the regular ones. And then you should see volume should say 0.00. And then the pH probe goes in the regular ones, and this is going to be a lot of cables. So it goes right there. And it should easily click in. If you are having a hard time putting it in, it means that you are putting it in the wrong place. The next thing you're going to do is you're going to set up your drop counter once you get your cables all ready. And we'll move them. And then you make sure that your cables are nowhere that will be around your liquid. And then we're gonna play with the height in a second. We're gonna fix the height. And then you wanna set up this one. All right, and to decide the height, you're gonna take your pH probe. So many cables. And then don't forget that the easiest way to unplug the pH probe is just to unscrew it, and be careful because it will drop, and then take it out. And then cap it. Don't forget that this is open, so it still will spill if you are not careful. And this goes right here. And then you're gonna take this right here, which is your stir, and you're gonna take it and stick it to the bottom like so. When you decide the distance of it, make sure that you can stir without actually hitting the bottom of the pH probe. And then you're gonna take either a 150 ml beaker or a 250 ml beaker. The 150 is the best one to use if you are able to use it. And then if you notice, my stir bar is way too high, so we need to bring this down. And once you decide this height, you don't move it again. You don't touch it again because we're gonna calibrate it. And every time you move it, you have to calibrate it. So you gotta make sure that once you set up your height, that's it. And then I'm gonna move it a little bit to the side. And actually, let's calibrate the pH probe first. So I'm gonna calibrate the pH probe first. You're gonna need a pH 7 buffer. There are multiple buffers. We're gonna use the pH 7 because we're gonna do a 1-point calibration. There are multiple calibrations that you can do. The 1-point calibration is the easiest one. So we're gonna stick that in there. And then we're gonna let it read. This one is the red one that says pH. Move the cables. So this one's reading at, just taking a second. So you want to make sure that you stir every time that you're measuring pH. All right, and it stopped. So now we can calibrate. I'm going to take my little pencil, and then I'm going to go click on where it says pH, click on the red screen, and then you're going to hit calibrate. And then you're going to hit 1-point calibration, which in your screen should look a little bit bigger than this. And then once you hit, make sure that you hit 1-point calibration, you're gonna click calibrate now. And then it will ask you for a value, that is the value of your pH. So this is just 7, which is our neutral, and then we wanna keep it. And then, okay. And then now you can see the pH reads at 7, which this buffer is neutral, so it should read at 7. So we calibrated this one. I'm going to stop it. Again, don't move the drop counter. Once you have a drop counter height, that's it. Because if you start moving your drop counter, then we run into issues. And then it helps if you have some water ready. Or if not, make sure that you have your distill water. So you rinse it. You want to make sure that you rinse it in between uses. And I'm going to leave this in there for now. Let me show you. All right. The next thing to do, and probably the hardest one, is going to be to calibrate your burette. So to calibrate this one, so this, if you notice, has 2 stopcocks. The normally that we use is normally 1 stopcock. So the whole idea is that when you're calibrating, you're going to set your flow rate, which is the speed of the drops, with one of them. So I like to do usually the bottom will be my flow rate, so I don't touch it ever again. And then the top is going to be my open and close. So I'm gonna put it in here. And this is not the most scientific measurement, but you want about 2 to 3 fingers height from, so your drops have to go through here, and you want to go about 2 to 3 fingers-ish. I know, not the most chemistry measurement, but it works really well. And then you want your graduate cylinder right there. So I'm going to close both stopcocks, and I'm going to fill this with water. You only need about 20 mil, 15 mil. You don't have to go measure it. Just make sure that it's about halfway filled. And then whenever you're ready, you're going to click. You're going to go here, go to volume. You're going to hit calibrate. And then it tells you instructions. It says that you are going to put a 10 mil. You're going to go from here to here until you're about 10 mils. And then you're going to stop it. You're going to read exactly how much you have and put it in a box. The third box in there says how much milliliters did you use. Now, this is going to be the one that's going to decide your flow rate. It's going to be the one that decides how well your measurements are going to be. So take your time with this one. This is going to be the most important one. And then once you figure out your flow rate, don't move it. Once you calibrate it, don't move it. You can move anything here. You can move this up and down, but don't move anything else, right? So to do this, I'm going to hit calibrate now first before I drop anything. So I'm going to go in, calibrate now. And then if you see it reads as 0 drops, so then make sure that it is right underneath it. And if you're not sure, you can start with a beaker. All right, so right now, if you notice, I don't know if you can see it, but the light is not going off. It means that it's not reading. So you need to find it until it is reading. So now you should see my little blinky light. It's reading. So I'm gonna have to recalibrate it. So I'm gonna dump this. And then I'm gonna press redo calibration. And it takes a second to read it. There we go. And then now I can do it. And you want a steady pace that you can see drop, light, drop, light. That's usually what you want to see. And then you're going to go through this until it hits 10 milliliters. And this part is a little bit slow, so we can speed this up a little bit. So now we're getting really close to, I'm gonna stop it, because we are exactly at 10 mils. So what I'm gonna do is I'm gonna take this down. And you wanna read, if you're a little bit below 10, that's okay. Whatever volume you're at is whatever volume you're gonna record. And this one, actually a 9.8. So I'm gonna go in and press 9.8. pH, whatever volume you read is whatever volume you input, and then OK. And then gave me 10.417. It's a little bit higher. You want to calibrate it a little bit until you get really close. It takes some getting the hang of it before you actually you're not going to get an exact volume. These ones are not going to read the exact same thing, but you should be really, really close. So I would calibrate it until I get around 9.5, between 9.5 and 10 milliliters. When you are ready, again, we don't want to move this. So to empty it, just open it, make sure that the beaker is underneath it. Don't move anything else. So now we are ready to titrate. We're going to start with the easier one, which is a strong acid, strong base. I'm going to show you the easier one, and then you should be able to do the more difficult one, which is they're going to be the weak base, strong acid. So while this is still open with the beaker underneath, I'm going to run some sodium hydroxide to make sure that it's clean. And then you probably need a little bit more. Okay, so I want to make sure that we run it with sodium hydroxide, so make sure you get rid of all the water. Don't forget to find your flow rate. Ideally, you don't want to move your flow rate if you can. There you go. All right, so I'm going to close it and then refill it with sodium hydroxide. Make sure, double check that it is sodium hydroxide. Remember that the sodium hydroxide and the hydrochloric acid look exactly the same. They're both colorless liquids, and the bottles look exactly the same. So I want to make sure that it says sodium hydroxide in it. And then I already pre-measure the hydrochloric acid. So you need 25 mils. Don't forget that you want to do it with a graduate cylinder. You don't want to eyeball it. So we don't eyeball anything unless it says like approximately. But if it gives you a specific one measurement, that's what you're going to do. So I'm going to take the 25 mils that I already measured and put it in my new 125 mil aromatic flask, because it's 150 mil. And then take the phenolphthalein indicator. And then your 2 to 3 drops is fine. And then I'm going to change this beaker that has just the water in it and the waste for this beaker. And then we can start our titration. Make sure that you have a really good flow rate. And then as soon as you're ready, not as soon as you start titration. You got to do this before you start titration. You're going to hit play, which is the lower button. And if it gives you a warning, just say discard. And then it will think it's normal, it does that. And then you want to turn on your stir bar. Double check that it's reading at a pH of 1. It might take a second and then you can start it once you are good to go. All right, so once you're close to 10 mils, as close to 10 milliliters as you can, and I am at exactly 10 milliliters. You don't have to be somewhere between 9 and 10 milliliters. You're going to stop it, and then you're going to get eye level with it. Make sure that you read the exact volume. And then at the number 3, it says enter the precise volume. You're going to click in the little box, and then I'm going to put 10 mils. And then done, and then press OK. And then it should get really close. It should be a little bit closer. So this probably means that I have to recalibrate it. You should be between 0.5 milliliters of whatever volume you read. But until you get that, I would calibrate at least twice. And then that is it for calibration. Then you're ready for your titration. Make sure that it is reading well before you go into your second titration. I would recommend try not to move anything between your titrations, because then you will have to recalibrate every time. If you leave everything as S, you do not have to recalibrate.
So we're going to be talking about data collection and potential errors, and we're going to be talking about this in general. It's going to apply to all of our labs, so this is going to be the same conversation you're going to hear for every lab, but I need you to pay attention to the same things and learn to apply them for each of the experiments. When we talk about data collection, there are certain pieces of data that you're going to be asked to collect. Depending on which lab it is, that's going to determine which pieces of data you're going to be asked to collect. It's not going to be the same every time. Sometimes we're going to ask you to collect one piece of data one time, and that's because we're interested in making one observation about that piece of data. Okay, so it's just one piece of information that we're going to collect that one time. That's typically a qualitative observation that we're looking to make, so just information without a lot of specifics about it. Okay. On the other hand, we may want to take that piece of data twice to see if it's reproducible. Okay. So typically if we're going to do that, it's going to be a numeric piece of data, and we're going to be very specific about how we take that piece of information. Now, we either take it once, twice, or many times. Now that many times is going to depend on exactly what we're doing and how we're doing it. In this class, we will limit that to 3. It never goes beyond the 3. But out in the real world, that many times could be 5, 10, 20, 50. Could be any of those things. The reason for that is because it becomes statistically significant. So if you've taken Math 120 and you know about statistics, you understand that we need multiple data points to be able to determine if those data points are statistically significant. So we need to know if that's really true for the data points that we've taken. We can't get rid of them if they look wonky, if we don't know what wonky actually looks like. So we need to take multiple points to be able to see if that data is real or not. Okay. We typically don't do that in this class until we get into the later labs. So the titration labs, the first times that we start looking at that number of data points. We do start taking more data points as we go forward. So in the beginning, we take 1 data point. Later on, we take 2 data points. At the very end, we start taking 3. If you have the privilege of taking CHEM111, then you get to take many data points the whole time. So look forward to that. Okay. Those are important things for us to be paying attention to. The other thing that you need to be thinking about is what kind of data are you taking? Because the kind of data that you're taking determines how precise you need to be with the information that you're collecting. The instrument that you're using typically gives you an indication of what kind of precision you need for that particular measurement. When we talk about the electronic balance, there's only a certain number of numbers on that balance that we can look at. There's no way we can estimate beyond those numbers. So that's what we're going to record. But when we talk about something that's a volumetric piece of equipment, we can usually estimate beyond the last thing that we can look at. So on a graduated cylinder, we can estimate beyond the last measurement that's there, in between those last measurements that are there, and so we can estimate that last data point. When we talk about something like a volumetric pipette, which is one of these guys, for this, there's a finite measurement that's here, and we can't estimate beyond that. We know exactly what that is, and so if this is a 1 milliliter pipette, we know that this is 1.00 milliliters. That's the precision that we know for that particular instrument. So the type of instrument that we're dealing with will tell us what kind of precision we have for that number. It's important that you pay attention to that and record exactly what it is. You will see that when we're in ALEKS, it will be very specific about that. So if you don't have the right number of numbers, that's going to be a problem. We need to know how many numbers it is, because that determines our number of significant digits, which then determines how significant those calculations are going to be, which then determines how significant our answers are going to be. So this becomes something that we have to carry through all of the calculations that we do. That's important. Okay. So that's all of the data that we collect, how we have to be careful with the numbers that we're collecting, and the type of information that we're looking at. Now, every piece of data that I collect has to have a unit. If I see numbers that don't have units, most of us will flip out about that. Okay? Units have to be there. Is it a gram? Is it a milliliter? Is it a kilogram? those are important. We have many times that scientific numbers are recorded in the US and then sent to the UK, and assumptions are made about what units those were, and then an assumption is made when they go to the UK, they do something with it, they make some kind of conversion about it because an assumption was made, and then they do some conversion to it before they send it back to the US, and then the US gets those numbers back, still without units. They do some other conversion to it, and then some $2 billion mistake happens. Welcome to the Hubble telescope. Okay? These things happen, and this is a really big deal. If you've made it one of those, been part of one of those calculations where a $2 billion mistake has happened, that's the kind of thing that gets you fired. So a simple putting the unit at the top of the column of numbers is a really big deal. So recording your units at the top of a column or with that number becomes very important. It's a habit you should be building now. So the numbers that you're recording should have those units, okay? So make sure you're doing that with your lab materials. Make sure that you're doing that on your tests. If they're not on your tests, that's a problem too. Okay, so those are the data that we're collecting, the number of significant figures that we have to have, the type of data that we're collecting, i.e. the units that they are, and then we need to talk about potential errors. Everything that I measure has a potential error that can go with it. So if I'm using one of these volumetric pipettes and I'm not particularly skilled at doing so, there are errors in the way that I may be doing that. It may be too high, it may be too low. There are inherent errors in that particular measurement. If I'm particularly precise in how I do it, then I don't have to worry about those errors. But if I'm not precise, I need to be honest about that, okay? That's something that I need to record when I'm doing my data collection. So if I say to myself, okay, I wasn't paying that much attention, it might have slipped down below where it should have been, I need to write that down because that's a potential error. That can affect a lot of the things that happen after that. Because if my volume was too small, then the concentration that I'm going to end up with is going to be too high because my mass is going to be in a smaller volume, which means a larger concentration, which therefore is going to affect all of the information that I'm collecting off of that concentration. These are implications that I have to be able to think about. Okay? So anything that you do may have implications down the road. So you have to think about what you did. If you took a mass on the balance, we always talk about it doesn't need to be exact. It absolutely does not. You do not need to spend a ton of time getting the exact number that we've asked you to get. Don't. It's a waste of time. But you need to record exactly what it was, okay? And if you do what some students do, and you don't bring your paperwork with you and write down that number when you're at the balance, and you walk away and then record the wrong number, then that's a problem, because you don't know if it's too high or too low. So one of the things that you need to be aware of is that when you go to that balance, you should be taking your paperwork with you to record that number at the balance. One of the things that I do to my students is if I see them walking to the balance without that piece of paperwork, is I will follow them from the balance back to their bench, and I will sing things like 8675309 so that they forget whatever the number is. Or if I see them writing it on a small piece of paper, then I will take that paper and burn it, because that's who I am. These are things that you really should not be doing. They're bad habits that you cannot afford. Okay, violations like that in terms of, federal regulations are $10,000 per incident per day violations. That's expensive. Okay, your company doesn't want that, and if you're responsible for it, that's something you can get fired for. Okay, so those are important things to think about. All of these errors have places where they can cause problems. We want you to think about the errors that you may have. When we ask you about errors, an answer that is completely unacceptable is human error. What the heck does that mean? What errors did you make? What could you have done? I may have made mistakes in measuring. Okay, what measurements could I have made mistakes with? Was I imprecisely reading my volumes because I was too lazy to pick up my thing so that I was reading the meniscus correctly. If that's the case, then maybe we should talk about making sure that we're having that meniscus at eye level so that we're seeing it appropriately. Okay? Are there things that we could do differently? Now, just because you're not aware of that at the beginning doesn't mean you can't improve on it as you go forward. That's part of the reason that we look at this after we do an experiment, because we're learning to look at how we did that experiment critically to see how we could do it better the next time. We need to be able to do that for ourselves and for the next person who does this lab so that we can say, hey, try this instead, do this differently, so that maybe you can do it better next time. That's an important part of our ability to be scientists, is to be critical about what we did. It doesn't mean you're wrong, it doesn't mean you do it badly, it just means that you have to be honest about what was done. Okay? So be willing to look at what you did and what are real places that you could have made a mistake. Okay? Those are important things. When we transfer solids, often we lose some of that material, so make sure that you've noted it places where that may have happened, especially if you actually see it during the experiment. You should write that down. You should talk about the fact that that happened. So any of those errors should be noted in your, in your paperwork, and it should be something that you talk about in the paperwork for your experiment. Okay? So those are the potential errors that you may see. Now, those are all going to be based on the particular experiment that you're doing. I'm not going to specify for each lab where those things may be, because it's your job to figure out where they might exist. Okay? This is a gentle reminder that you need to be looking at every experiment to see what kinds of things was I recording, what kind of mistakes could I have made, what things do I need to be paying attention to. So that's my spiel about data collection, units, errors that you might have made, and how those errors could implicate the data that you're looking at. So hopefully that will help you with some of those things and get you on the right track. Thanks, guys.